Okay, so open up the Math Excel assignment that says, it should say Math Excel 23. Okay, so yesterday we went through these, there was like 4 problems on this Math Excel classwork. So there was 4 problems on that you had to do. We did those in class. So for you girls at home, you want to do this one as well. And this was just practice from yesterday. And if you get stuck, ladies, I made a video of us doing those 4 problems from the one that says Math Excel classwork November 3rd. And that video of how to do those, if you need help, is right there. All righty. So we're going to open that Math Excel up. Here. Yeah. Okay. Thank you. All right. So let's go to Math Excel and open up that guy. And ladies at home, if you got a question, just ask it. And I've got the audio on. So okay, so I moved the test to Friday, and today we're going to work through the review here. And then you're going to open up the one that says Math Excel 23, graph, sine, and cosine test review. All right, so we're going to go through this and make sure you understand what it's asking you, and then show you how to use the GeoGebra applet to answer your question. Okay. All right, so here's what this is asking you. It says move the slider from a point 1, 0, move the point counterclockwise in a counterclockwise direction. All right, notice the points that are being traced out. The x coordinates represent the measure of the angle, and the y coordinate represents the y coordinate of the point corresponding to that angle on the unit circle. All right, so let's click on this, and it should open up something that says sine curve on it. All right, now when you open this up and you start to hit right down here where it says drag me, is right there when I clicked on that and I start dragging it, the first coordinate right here, the 0.95, that's the angle. And the second coordinate, this one in blue, 0.31, that's the y coordinate right here. All right, so this is the angle, this is the y coordinate. And then what it's doing is it's plotting those, okay, as I move around. So I go back and forth. Now I'm at pi over 2, 90 degrees. And I just keep going. And I can go back and forth, and it's going to fill in all those. Okay, that is your sine curve. All right. Now, if you click Show Graph, it draws it in for you. So now we got a nice sine curve. All right, now let's use this to answer the first question. All right, so the first question's asking you, as the angle increases from 0 to pi over 2, which is 1.57, the value of sine increases from 0 to blank.
Teacher, please excuse this interruption. This time, please visit all band members to the band room. All band members to the band room.
Okay, so when you look at this right now, okay, as I start to drag this, right now the y coordinate is 0. See, I'm pointing at it. Okay, now as I pull that along, watch what the y coordinate does. So the y coordinate's 0, y coordinate's 0.53, y coordinate's 0.73, y coordinate is 1. Now the angle is 1.57. That's pi over 2. That's 90 degrees. So as you start at 0, if you go from 0 to pi over 2, what does the y coordinate do? So the y coordinate, here's the y coordinate, I'm pointing at it. Now as I drag that blue dot up to pi over 2, what did the y coordinate increase to? Pardon me? 1. It starts at 0. You're looking at the purple y coordinate right there. So when I move the angle up to pi over 2, the y coordinate goes to 1. Now, if I keep going and I move it to pi, what does the y coordinate do? Now what did it do? Did it get bigger, smaller? Okay, here, let's start again. Okay, as I move this to pi over 2, the y coordinate starts at 0, and when I get to pi over 2, it is now 1. When I go from pi over 2, which is 90 degrees, to 180, what does the y coordinate do? Say it a little louder. It turns back into 0. Okay, when I go from pi to 3 pi over 2, where does the y coordinate go to? Colton?
Go from where?
From pi, right here, look, what's the y coordinate? Right there, up, there, up, close. It's going to be 0. And as I go to 3 pi over 2, it's -1. And now as I go from 3 pi over 2 to 2 pi, right. So what the y coordinate's doing, okay, it's increasing, watch. The y coordinate increases to 1, then it decreases to 0, then it decreases to -1, and then it increases back to 0. So these questions are just asking you, this would be in the first quadrant, what's the sine coordinate doing? It's increasing from 0 to 1. Okay, that's the question. Now you're going to do it, what does the y coordinate do from pi over 2 to pi? Okay, so I'm going to go back to this and go from pi over 2. Okay, I'm just click show graph so you can see the whole thing. Okay, I'm going to go to pi over 2. It's 1. Now I'm going to move from pi over 2 to pi. You can use the arrow keys too on your calculator. All right. Now it was at 1. At pi over 2, it's 1. And then it decreases to 0 when I'm at pi. So the answer to this part is from pi over 2 to pi, the sine value decreases from 1 to 0. All right. What happens as the angle increases from pi to 3 pi over 2? Okay, so now I'm going to move it to pi. So increases to 1, decreases to 0. Okay, so there it is at pi. Okay, now I'm going to move the angle to 3 pi over 2. What does the sine value go to? Angel? Come on, get off your phone. Look, you're at pi. Okay, right now I'm at pi. What's the sine value up there? Look at the y coordinate. What is it? Look at, that's the x coordinate. Look at the y coordinate. The y coordinate. 0. Okay, now, as I move the angle to 3 pi over 2, what does the y coordinate move to? Yeah, -1. Okay, so what's going to happen here is that the y value decreases from 0 to -1. And then the last part is what happens when you go from 3 pi over 2 to pi, right? So there we are. That's 3 pi over 2. And now I'm going to move it to 2 pi. All right, Caleb, what did the y coordinate do? It went back to 0, right? So it went from -1 to 0. So all you're doing on this, guys, is you're explaining what the y coordinate is doing. Okay, so when you look at this graph here, if you click on show the key points, it gives you the y coordinates. All right, what do you need? Yeah, go ahead. All right, so let me show you what I Control V. That. All right, so here we go. Tell me what the y coordinate does as I move through these different quadrants here. Okay, so let's see. Here are the y coordinates. I'm highlighting them. Let's see, y coordinate, y coordinate, y coordinate, y, y, y. Okay, all right. As you go from 0 to pi over 2, what does the y, how does the y coordinate change? All right, so let's see. Isaiah, at 0, what's the y coordinate? Okay, And then what does it increase to when it reaches pi over 2?
1.
Yep. So it increases to 1. All right. Now at pi over 2, we're going to go now to pi. So right now it's the y coordinate's 1. And when I reach pi, okay, Caleb, what's the y coordinate now? 0. Okay. And now as I go from pi to 3 pi over 2, okay, what is my y coordinate doing? Angel? 2, what? -1, yeah. So that's all you're doing on the problem, guys. And then as I go from 3 pi over 2 to 2 pi, the y coordinate increases from -1 to 0. All right, that's what you're describing on that problem. All right, let's go on to the next one here. What do you put? We typed them in here a few minutes ago. Here, I'll go back. No, problem 1. Okay, so we did 1, and then that was 2, and now we're on 3. Okay, 3 is a different, this one is, no, it's the same thing, but it says, check the box that says show graph. Notice the graph of the sine function continues indefinitely in both the negative and positive directions, suggesting the domain is the set of all real numbers. Okay, hit the reset button in the upper right-hand corner, uncheck show unit circle, and check the boxes show graph and show key points. Based on the graph, what is the range of sine? Okay, so we open this guy up. Okay, if I hit that little reset button, I'm gonna click off show the unit circle. I'm gonna click show the graph, show key points. Okay, now based on that, what is the range of sine? How do we get the range? The domain, it goes on forever. The domain is how far it goes to the right and to the left. So this graph would go on forever to the right, and it would go on forever to the left. So the domain is from negative infinity to positive infinity. Okay, what's the range? So how do we find the range of that function? What do you look at to get the range? Not the x, the y coordinates. Okay, so by looking at the y coordinates, what's the range of this function? Jackson? Jackson? Mm-mm. All right, so it looks like we got a little confusion on what range is. Range is the highest y value. So that's the highest y value and the lowest y value. Yeah. Now, the graph passes through y equals -1, and the graph passes through y equals 1. So we write bracket, and you work from the lower to the upper, -1 to 1. That's the range of a sine curve. It's just the highest and the lowest values, that's all. Right, so we answer that. Let's see that. And I'm going to type it in as bracket because it passes through -1, 1 bracket. Check the answer. All right, now this one says you're gonna check the show graph, uncheck the show unit circle, and check show graph and show key points. And then the question's asking, the graph of the function y equals sine x is symmetric with respect to the blank, and the sine function is a blank function. Okay, so what's the symmetry on a sine function? Right, so probably the easiest way for me to show this to you is with a drawing. Okay, so you're going to look at the graph that you make, and I'm going to show you a drawing. Click on this. Right now, you folks at home can see my keyboard. All right. Focus. All right, so when we learned about symmetry, second. There it is. Okay. Okay, here's a sine graph. Okay. So sine graph 1, 2, 3, 4. Okay. Sine does this. This is 2 pi. Hey guys at home, is that backwards? Pi. All right, now this is the top of the paper. Okay, and here's my sine curve. Now, if you take a sine curve, and I'm going to take my paper and turn it upside down, the sine curve looks the same. It didn't change. Turn it right side back up, it's the same thing. So when that happens, we say that the sine curve is symmetric with respect to the origin. with respect to the origin. Because when I spin it around the origin, it looks the same. Okay, that was the definition of what makes something an odd function. So sine is symmetric with respect to the origin, and it's odd. Okay, so let's go back to our slide. Okay. And now when we answer this question, sine is symmetric with respect to the origin. The sine function is an odd function. Okay, now I'm going to ask you either that one or I'm going to replace it with cosine. Okay, so if I did it as cosine, okay, here's a cosine graph. Okay, and here's what cosine looks like. Okay, now that's cosine. Now, if I take that, here's the top of my paper, and I spin it around the origin, is it going to look the same? Nope, doesn't look the same. So cosine is not symmetric with respect to the origin. Where it is symmetric is if I took it and I folded it over the y-axis. Now, the part on the right is going to go exactly on the part of the left. So this one is symmetric with respect to the y-axis. And we call that an even function. Okay, so sine is odd. You can turn it upside down. Cosine is even because you can fold it over the y-axis. All right, let's move on. Okay, so, all right, now go to the next animation. Okay, and it says, check the function box for sine. Use the A slider to graph f of x equals sine x. The value of A affects the blank. So you launch that. Here's how you change the function. Look at go in the top left-hand corner, and you're going to pick sine. Then you're going to hit plot function. Okay, that's a regular sine graph. And we want to see what happens when A is 5. So I'm going to go up to A, and I'm going to drag the slider to 5. And there's the new graph. Okay, so based on that, the A value affects which choice? See? What does the A value affect? The amplitude. All right, now you're going to change it to cosine, and you're going to use the A and the B sliders and figure out what the value of B affects the blank. Right? So launch this. I change this to cosine. Plot it. There's your cosine graph. All right, and then A is 3, B is 4. So I'm going to move A to 3. Now this is the one we want to look at. Right now, the period of cosine is 2 pi. I see one cycle of cosine on my way from 0 to 2 pi. Now I'm going to take B and change it to 3. Or change it to 4. All right, now based on that, I'm going to answer this question. B affects the blank. Okay, Jacob. Or let's do Jose. Pardon me? I'm sorry, I can't hear you. Yes. The value of B affects the blank. The period. Yep. Okay, now you're going to use the A and the C sliders, and you're going to build this equation. 4 sine x plus pi over 4, and the resulting shift for C value is negative pi over 4. Okay, so we launch it. Okay, there's my normal sine, and A is 4. And now I'm going to make B or C negative pi over 4. So as I move it to the left, negative pi over 12, pi over 6, pi over 4. And that's what it did. So you can see it slid it pi over 4 to the left. Now I just answer the questions. Results in a shift, negative pi over 4 units. And you do it for your values, negative pi over 4. And that one was left. Uh-oh. Oh, it's just pi over 4, yeah. Yeah, so I don't need the negative on it. There we go. Okay, use the A and B sliders. How many complete periods are on the interval from 0 to 2 pi? And the function is 4 cosine 3x. Okay, so I'm going to go up here and change this to cosine. Amplitude 4. Graph it. Right now, I see one cycle of cosine. Right now, I'm going to change the B value to 3. Okay, So that's going to go to 3, and that is going to horizontally squeeze it right there. And how many of them do we see? 3. There's 1, there's 2, and there's 3. Okay, so now I can answer that question. It's whatever that B value is. That's the shortcut. B is 3. That's how many complete periods I'm going to see. All right. What is the amplitude? 5. Yep. Next question. Check the answer. Okay. Jace, what's the period of 5 cosine x? 2 pi. 2 pi. Okay. All right. Next one. John. Up front, John. What is the amplitude on mine? Say it again. 5. Notice John did not say -5. Amplitude is always positive. Even though there's a -5 there, the amplitude is 5. Okay. What is the period on that? Ruben, how are we going to, on mine, how would I get the period? Not multiply. Divide. Divide what? Yep. So I'm going to have pi over 2 divided by 9. And we can't do any simplifying on that. Pi over 2 divided by b. So that is my period. That is going to be 2 fraction. Okay. 2 pi. All right. Now the next one is this, all this matching. Okay. So let me give you a couple of little hints on how to match these up kind of quick. Now yours could be in a different order, so, and have a little bit different numbers. Okay, so first of all, to kind of speed things up, look at the amplitudes. All right, so on mine, I got amplitudes that are either 3 or 4s. All right, so if you look at your drawings here, okay, anything with a 3, that's going to belong to, all of these are 3s. So there's only 3 that are made up of 4s. Okay, this is a 4, this one's a 4, and this one's a 4. All the rest of them have amplitudes of 3. All right, so I could probably move those first. I'm going to take care of the ones that are 4s. Okay. All right, so I'm going to look at, remember what your graphs look like. It's up on the whiteboard. Okay. So I got a sine graph, So in front of the classroom, you got sine, then you got negative sine. And then you got cosine, and you got negative cosine. So I'm going to do these, the ones with 4s in them first. All right, so if I was doing this problem, all right, so I'm looking for a regular sine that has an amplitude of 4. So remember the ones I'm looking at here, amplitude of 4, amplitude of 4, amplitude of 4. So it's got to be one of these three. And it's a regular sine graph. So it's going to look like this one right here. So that one doesn't look like it. That one doesn't look like it. That's the only one. And this would be, it's got the right amplitude. And if I look at the period, here is, that's kind of hard to read. I should see 3 of these between 0 and 2 pi. And I can't even read the writing there. Okay, that's 1. That's 2, and it's at 5 pi over 4. And by the time I get to pi over 2 or 2 pi, I'm going to have 1, 2, 3 of these, 3 cycles. Does that make sense or not really? Okay, the next one, so I got that guy done. Now I'm looking for an upside down cosine. Right? There's only one upside down cosine there. This guy right here. That's going to be negative cosine 3x. That takes care of that one. And then this is a positive cosine. Any questions on how to get those? Okay, the periods on these guys, this would have a period of 2 pi over 3. And if you trace the cosine, there's one cosine, and it takes to 2 pi over 3. Okay, this one would have the same period. So if I do one sine curve, that distance right there is 2 pi over 3. That's how long that cycle is. All right. Now, the other ones that are easy to put on here are the ones that have pi's in them. Okay. Let me show you. So I got rid of this one, this one. Okay, look at the ones, the b values that have pi's in them. So this is a b, this has a b value with pi, and so does this one. And they got amplitudes of 3. One's a cosine and one's a sine. And here's another one. Now, to get the periods, I take the period of this one is going to be 2 pi divided by pi over 2 times Those cancel. And the period is 4. So I'm looking for an upside down cosine that has a period of just plain 4. So here's how you know on here. This x-axis doesn't have any pi's on it. This x-axis doesn't have any pi's. And there should be one more. This one right here. Okay, so the 3 that I put an x above up there, they're going to have to go in those 3. Because the x-axis don't have any pi's in them. So we've got to find an upside down cosine whose period is 4. So here's an upside down cosine, and its period is 4. That is going to be this one. All right, and then I'm going to do the same thing. This one over here is just the same graph, but right side up. So that's right here. That period there is 4, so this one is the 3 cosine 2x. And then the only one left has to go with the sine. All right, so tonight, finish this up, and then we'll go over the remaining questions tomorrow, and we'll take the test on Friday. Match up the remaining ones, and then do the rest of the questions.